Hello and welcome back. So in the previous segment we were talking about the different parts of the Earth's atmosphere, and we mentioned that the stratosphere helps to block ultraviolet light. So now we want to do this in a little bit more detail. So we said that in the stratosphere the main component would be ozone. So ozone is going to be O3. Now, you can't breathe it, so don't get the idea just because it's got oxygen in it that you can breathe it. So what you can breathe is O2. Now, what happens up there is that O3, when ultraviolet light comes in, it then breaks apart the O3 into O2 plus oxygen. So we started with O3, and now we've got O2, which you could breathe, and then regular oxygen. Now, the problem, though, is if you get out your periodic table and you look at oxygen, you're going to notice that oxygen is in column 6. So it's got 6 outer electrons, 6 valence electrons. And it wants to have 8, because that was the magic number. So oxygen is very reactive. It reacts with a lot of different things. In terms of chemistry, it's called a radical. And so it's going to react with things. Now, normally in the stratosphere, the oxygen will recombine with the O2 to make O3. And so it just repairs itself. So it remanufactures the O3, and in the process, what comes out is infrared light. So ultraviolet light went in to break apart the ozone, but when the ozone reforms, infrared light is given off. Now, infrared light's not going to hurt us. That's heat. Ultraviolet would, because ultraviolet would make skin cancers and cataracts. So again, the ozone layer protects us. Now, if that was the whole story, well, it has a happy ending. But the problem is that we have put into the atmosphere these things called CFCs. So the word CFC stands for chlorofluorocarbon. And so what elements do you think would be in it? So chloral means it's got chlorine, fluoral means it's got fluorine, and then carbon means it's got carbon in it, chlorofluorocarbons. And what do we know about chlorine? So chlorine is in column 7, which means it's just needs 1 electron, which means this is even more reactive than this. And the same thing with fluorine. So fluorine's in this, it also has 7 outer electrons, and it wants 8. So both of these are going to be highly reactive elements once they get into the stratosphere. Now, we used these things, chlorofluorocarbons, because they were very cheap to make, and they could be used in a wide variety of things. So like aerosol cans, they made very good propellants. Also, they were very good in air conditioners. But the problem was that, let's say your air conditioner conked out, and the person would come over to refill your Freon, the thing that makes your air conditioner run. So what they would do is they would basically take off the cap, allow all of that Freon that contained these chlorofluorocarbons to go into the atmosphere, and then they would pour in some more Freon, and then they would cap it back off again, and away you'd go. Well, we didn't know that we were damaging the stratosphere for something like 40 years. So for 40 years, these various chemicals were making their way through the troposphere and then into the stratosphere. So what happens in the stratosphere is that these CFCs, when they get hit by ultraviolet light. They break apart, and one of those chlorines comes off. And then, because that chlorine is so reactive, it reacts with the ozone more than it should be. And so the ozone is destroyed by these chlorofluorocarbons. Now, given enough time, though, these chlorines will destroy themselves, and then everything's okay. But it's like one molecule of CFC can destroy 1 million molecules of ozone before it itself is neutralized. So we were really damaging the ozone layer for many, many years. And so it wasn't until actually people down in Australia started getting a lot of skin cancers and cataracts that we realized that the ozone layer was being depleted. So what we have done so far is, at least in the United States, we have stopped manufacturing CFCs. And as a result, the ozone layer is getting better up there. But the problem is that there are some countries that are still making ozone CFCs today and are contributing to the damaging effects in the ozone layer. So I will let you go to the internet and find out what countries are still manufacturing CFCs. But that's one of the problems with CFCs. So what we've done is we've gone to other substances that can be used in your air conditioner. And so that's the reason why when they fill up your air conditioner and they fix it, they give you an additional charge, because it costs money to capture the old refrigerant material and then to dispose of it safely. So there's a cost to doing this. So there's a little video that I'd like for you to watch here. It's called Climate 101 Ozone Depletion by National Geographic. And so it's on YouTube. So go ahead and watch that. So let's take a look here at the ionosphere. So that was the level that was above the stratosphere, and this is the part that gets bombarded by X-rays and gamma rays and becomes ionized. And then when those electrons reattach, then you get your light, and so this is the auroras. So that's a picture taken from space. Okay, in our next segment, we're going to talk about the magnetic field of the Earth and what it does.